Solving. This is the step where we're going to include, oops, too far, where we're going to include the zero product property. So remember your steps. One is always that GCF. Can I pull something out to make this problem easier? Step 2, factor. Step 3, set each factor equal to 0 and solve. Set each factor equal to 0 and solve. Your degree, the degree of the problem, the degree of the polynomial tells you how many answers you should get when you solve. So number 13, it's set equal to 0. So I can start in on solving. Do they have a greatest common factor? No. So now when I factor, this a value is not 1, right? It's a 2, so we can't just use our x. We have to use our x and our box. 2 times 5 is 10. The b value is negative 11. Two numbers that multiply to a positive 10 but add to a negative 11 have got to both be negative. And in this case, negative 10 and negative 1. I want to show you a second method because some of you really like to use the old-fashioned arrows, and I want to show you that they still work to do that if you're using your FOIL method. That when you're doing this, if you're using your old school FOIL, then you also have to use the old school factor. So you write, what are the pairs that multiply to 2c squared? It's 1c times 2c, that's all there are. And you write the pairs that multiply to the constant of 5. 1 times 5. If there were more, we would list more. There aren't. Because we know that the b value has to be split into two pieces, one being negative 10 and one being negative 1, then we would just go ahead and make a negative and a negative. And 2 times 5 would make a negative 10. 1 times negative 1 makes a negative 1. And those of you who like a box, use a box. It's my preference. I don't like this method, but it works. So we would put 1c in the first part of the binomial, and 2c goes as the other firsts, right? There are your firsts. Here are your lasts. And to decide how to connect them, we use our O and our I. So we use our outer and our inner. The c, or 1c, gets connected to minus 1. 2c gets connected to minus 5. And your box is much easier. There's no guessing. When these problems get more difficult, using this method is not always the best bet. But you can. We need to finish it. This one is a solving problem. Notice it has equal to 0. That's how we know it's a solving problem. And we need to use our zero product property. So we need to say c minus 5 equal to 0. So c could equal 5. And 2c minus 1 could equal 0. So 2c, adding 1 to both sides, so that c is equal to 1/2. A degree of 2 with 2 answers. Let's try number 14. Again, if you like the X in the box and you're feeling really comfortable with it, continue to use it. I want to show those of you who like FOIL method, or you like the old-fashioned arrows, I want to show you how your old-fashioned arrows can continue to work for you. So I'm going to do number 14 that way. So we're trying to solve. First step is to make sure it's equal to 0. I better put that in there. I'm going to put that up here at step 1, equal to 0. Once it's equal to 0, then we start in our factoring steps. Greatest common factor, 15, 2, and 8. They don't have one, and this 8 is a constant, so I can't use a. So I have to use my factoring, no GCF. I have to go right to factoring. Again, I'm using my old school, so 1a times 15a. But I also have 3a times 5a. Pairs that multiply to negative 8 would be 1 times negative 8 and negative 1 times positive 8. I have 2 times negative 4, and I have negative 2 times positive 4. I need to connect these two together so that I end up with two things that subtract to negative 2. A pair that subtracts to negative 2. So that the connections would be, 5a to positive 2 and 3a to negative 4. So that my two quantities equal to my firsts, 3a and 5a. Use your arrows, your outers and your inners. The 5a connects to a positive 2, and the 3a connects to a negative 4. It's a solving problem, so I finish by saying 3a plus 2 could equal 0, and 5a minus 4 is equal to 0. So 3a equal to negative 2, and a is equal to negative 2/3. 5a is equal to 4. A is equal to, dividing both sides by 5, 4/5. So regardless of whether you use old-fashioned FOIL arrows or you use your X and a box, you should end up with the same factorization and the same solving. It's just this work here that might be a little bit different. Let's talk about number 15, and this one I'll do with an X and a box so that you can see that work with solving, since I haven't done one with solving an X and a box. So we start with, is it equal to 0? Yes. Can I pull out a greatest common factor? I have a leading negative, so I'm always going to want to pull that leading negative out. So if it's a negative 2, great. But if it's not, then I have to pull out a negative 1. So this problem is just a greatest common factor of negative 1, leaving me with 2y squared plus y minus 10 equal to 0. Excuse me. All right. So this greatest common factor is just going to tag along till I get to the solving step. I promised I would use my X and a box for those who like that. A times C, a B value. They have to multiply to a negative and add to a positive. So multiplying to a negative means one of each. And 5 times 4. They multiply to a negative 20, add to 1. I use my box. So once we get down to our solving step, we always look at that greatest common factor, make sure it doesn't have any variables in it. If it doesn't have any variables, we can ignore it. If it does, then we would have to set it equal to 0. So if you want to just kind of give yourself a reminder, negative 1's never equal to 0, so I don't even have to worry about that. 2y plus 5 could equal 0, and y minus 2 equal to 0. That's another solution, or another 0. 2y equal to negative 5, so that y is equal to negative 5 over 2. and y equal to, add 2 to both sides, a positive 2. And we get 2 answers. Degree of 2, 2 answers. In numbers 16, 17, and 18, they just changed the directions slightly, and the format, it still says find the zeros of the polynomial, so we're still going to solve, but since we have to find the zeros is what they told us to do, we simply need to replace the function notation with a 0. So g of x or f of x, h of x, whatever that is, just change it to a 0. 0 is equal to 3x squared minus 13x minus 10. I want you to practice with these 3 problems. So we'll go ahead, practice them, push pause, come back, and I'll have the answers up for you. Pause it up. All right, hopefully you've checked over your work and that you did just fine. I'm pretty confident in this work and that you'll be all right. I will see you in class on Wednesday or Thursday.